Okay, as promised, we're going to look a little bit at the graph of this function, okay? If x is a big negative number, then you have a big negative number times a big negative number divided by a big negative number. Now, one big negative number divided by the other, well, these both have x's in them, so this big negative number is going to be much different than this one, so if we divide them, we get 1. But that's going to still leave us this big negative number. So we know that when x becomes a big negative number, the value of y is going to become a big negative number. So the graph is going to go down kind of like this. Now we can actually verify that the graph is going to have a slope approaching 1 as you go down here, because the factor that you have left over in the numerator has a slope of 1. And I'm not going to talk about that right now because I want to lay the basics on you. Your text addresses it, and some of your problems address it, and you'll see how that works. Okay? Now, if x is a really big positive number, well, it's going to be the same thing. You divide, the denominator is going to be about the same as the numerator. If x is 1,000,000, if you divide 1,000,002 by 999,997, those numbers are both close to 1,000,000. You get something very close to 1. It leaves you this, okay? Whichever one you want to divide by x minus 3, doesn't matter. Whether you have this one or this one left over, it's going to have a slope of 1, so that as you approach very large numbers x, this thing's going to have a slope that approaches 1. Whether you understand that or not, you can understand that when x is a really big positive number, two of these will be really big positive numbers, but it'll leave you a really big positive number, so y is going to approach a really big positive number, and the thing is going to take off. Okay. Now, we determined between -3 and -2 that the graph is positive, so that's how we have it. It's got to be 0 here, it's got to be 0 here, but it's going to leak up above the axis a little bit and then come back through the axis here, and then it's going to go negative because, of course, it has to be negative between -2 and 3. Now, let's look at what happens as you approach 3. So I've written some stuff out in green here. Okay, we haven't talked about that yet, but I'm going to say, okay, x is 3 here. Near x equals 3, x squared plus 5x plus 6 is near 30, because 3 squared plus 5 times 3 plus 6, that is, you plug in 3 here, you get 30. You get 9 and 15 and 6 adds up to 30. Okay? So, if x is 3, this is 30, and if x is close to 3, it doesn't take much convincing for you to believe that this is going to be close to 3. How close? Well, we'll leave that unanswered for the moment. Now, if x was equal to 3, the denominator would be equal to 0. I mean, that's how we got to 3 here. We found that to be a 0 over the denominator. And you can't divide by 0, so you'd be dividing 30 by 0, but you can't do that. But what's going to happen is, if you're close to 3, you're dividing 30 by a number that's close to 0. Now, if you divide by a number that's close to 0, what do you know about the result? Well, a number close to 0 will go into 30 a lot of times, and the closer that number is to 0, the more times it'll go into 30. 1/10. 1/10, it goes into 1 10 times, right? Because you can count 1/10, 2/10, 3/10, count them on your fingers. It goes in 10 times, and then it'll go into 30 times that many. It'll go into 30 300 times. 1/100th goes into 1 100 times. Go ahead and count that one on your fingers. It only takes a minute. Of course, you don't have enough fingers. But, so it'll go into 30 times 100, 3,000 times. Okay? The smaller the number you divide into 30, the bigger your result is going to be. Now, when I say bigger, it might be bigger positive, it might be bigger negative, depending on whether this tiny number that's near 0 is positive or negative, because of course if you divide 30 by a tiny positive number, you're going to get a big positive result. If you divide 30 by a big negative number, you're going to get a big negative result. Okay, well let's think about how this works now. As x gets closer and closer to 3, you're dividing your numerator, which is close to 30, by what? By a number that's going to be a little less than 0, okay? Okay, now why is that? I should have explained that, but if x is a little bit less than 3, then x minus 3 is a little less than 0. So x minus 3 will be close to 0, but it'll be negative. So just to the left of 3, we've got a very small negative number that has to be divided into the numerator, which is close to 30. Well, what do we get if we divide a negative number into 30? We get a negative result. And if that number is a small negative number, we're going to get a big negative result, meaning y is going to be a big negative number. Now, the closer we get to 3, the tinier that big negative number is going to be, or the tinier that x minus 3 number is going to be, the tinier denominator is going to be. So the bigger your negative number is going to be, and what's going to happen is your graph is just going to get bigger and bigger and bigger in the negative direction. There's no limit to how small x minus 3 can be as x approaches 3. So there's no limit to how big your negative result is going to be. So you have what we call a vertical asymptote, and it's a negative vertical asymptote. Okay, on the positive side, if x is a little bigger than 3, well then x minus 3 will be positive. Anytime x is bigger than 3, if you subtract 3, you get a positive number. But as x gets closer and closer to 3, that positive number gets closer and closer to 0. A positive number that gets closer and closer to 0, when divided into 30, gives you a bigger and bigger positive result. So you have this vertical asymptote here. The closer x gets to 3, the bigger y gets in the positive direction. There's no limit to how close x can get to 3, so there's no limit to how big this result can become. Okay, so at x equals 3, we have these asymptotes. Negative on this side, because between negative 2 and 3, you've already verified that the function values have to be negative. And we just explained why the function values have to get really big as you get close to 3. So you get a big negative number, negative asymptote. To the right of 3, the function values are always positive. You get the closer you get to 3, the tinier the denominator gets. So you're dividing a tiny number into a number that doesn't change much, a number that stays near 30. You get this behavior. Okay, an asymptote, a curve that gets closer and closer but never touches this vertical line through x equals 3. Where does that leave us? Well, we see what's going to happen here. Now, we come down here and we got to go through 2, so we got to have some kind of a slope as we go through 2. But that slope might possibly just get bigger and bigger. So the thing might come through 2 and then just curve down. Now, I've got it doing something a little more general. And you don't have the means to determine which way this thing actually, whether the thing actually acts like what I just described or like what I drew. So I just kind of drew something arbitrary here, where the value kind of starts to level off, but then as x gets too close to 3, things start to deteriorate, and the function approaches the asymptote. So this could have been drawn like this, so that, approaches the asymptote like this, but I chose to level it off here a little bit and then let it decrease. Again, other than just plugging in a lot of numbers, you don't, in a pre-calculus course, have the means to determine which kind of behavior it is. So it doesn't really matter what you draw. Just draw something with a bunch of loops in it going down here. Of course, we know not to do that. Okay. Now on this side, we've got to come down from really big positive numbers, but we can't go through the x-axis because we can only go through the x-axis at a critical point. So we're going to come down here, but we gotta end up going this way. So we're gonna have to eventually turn around, and we're gonna have to do that before we get down to the x-axis. Now, we don't know how high or low this is. Again, you don't have the techniques to determine that. It's a fairly simple thing to do that for this function using calculus, but we don't have that tool. So you just have to be sure you draw it so it has this asymptote, and then so it goes off increasing toward infinity and doesn't go through the x-axis.